Hello everyone. It's time for another written exam. This is for Module 2, Chapters 2, Sets and Whole Numbers, and Chapter 3, Numerations and Computations. I am Miss Akeisha and I look forward to working these problems with you. Alright, we're going to do 6 questions today. I'm only going to do a couple examples from each, okay? Get my handy dandy little pen and we can start analyzing our first question, which says let U be A, B, C, D, E, F, G, H. A is B, C, D, G, H. B is D, F, H. And C is D, G, H. And we're going to create a 3-loop Venn diagram to show all 8 elements of U. And then we're going to list the elements in the sets. All right, we're going to do E and F. But first things first, let's get our 3-loop Venn diagram drawn. Here's our universe, U, with A, B. Remember, this is an art class, so they don't have to be perfect. And C, because I would probably not make a passing grade in art. That's what we were doing. All right, let's get to placing the letters in our spots. So A has B, C. Looks like D is in all 3, so we'll place that in the center. G looks like it shares it with C, so let's put it right there. Oop. Might help if I finish the G. Then we got H. Looks like they all share H. All right, so B, is there anything we haven't used yet? There's F. And we've used all 3 of C. But let's go back to our U. We haven't used A or E. So first one, E, is the complement of A. And if you remember, the complement of A means that it is everything that isn't an A. So let's look at A. And looks like the letters not in A are A, E, and F. All right, and that's all you have to do for that one. On to the next one. A little cursive F for you there. And that is A union the disjoint of B and C. If you remember, disjoint means that it is what's in common between B and C. So it looks like the only letters in common are D and H. And union is what all encompasses the 2. So all of A plus D and H. So all of A, D and H. So that's going to give you B, C, D, G, and H. And let's check our answers. A, E, F, you can kind of see it there. Ignore the B and C between them. And then B, C, D, G, H. Yep, all right. Let's move on. So the 12 shapes in the Venn diagram shown to the right are described by the attributes shape, size, and color. So C, H, and T are going to mean circular, hexagonal, and triangular shapes, whereas S, L, R, B is going to denote small, large, red, and blue. So if you take their example, A equals S, disjoint, the complement of T. And that's going to mean shapes that are small and not a triangle. See? That makes sense? So let's take a look at these. We're going to describe shapes that are C union with H. So circular with hexagons. That means all shapes are going to be circular and or hexagons. Circles, hexagons. Woohoo! C describes the shapes which are T in the complement of R. So triangles that are also not red. And the last one, shapes that are C, disjoint of S, disjoint of R. So circles that are small and red. Small red circles. That wasn't too hard. Just a little bit of extra practice for you. All right. Here's a little bit harder one. We are going to take Indo-Arabic equivalent symbols and figure out numbers. We're going to translate. So each of these little pointer fingers equal 10 to the 4th power or 10,000. These upside down U's are just 10. And then tallies, those are simple. They're going to be 1. So if we take a look at this, we got 3 times 10 to the 4th power. We got 5 times 10. And then 4 times 1. And that's going to give us 3,000, or 30,000, sorry, plus 50 plus 4. 30,054. Not too hard. The Roman numerals are a little bit tricky though, because M is 1,000. C is 100. X is 10. V is 5. And again, these little tally marks are going to be 1. But the thing is, usually you see them decrease from largest to smallest. Well, you see the C is in between 2 M's? That means we're going to subtract this C from that M. So it's going to look like 1,000 plus 1,000 minus 100 plus 3 times 10 plus 5 plus 2 times 1. So 1,000 plus 900 plus 30 plus 5 plus 2, giving us a total of 1,937. Wasn't too hard now, was it? Right, moving on. Right, this one we're going to use lattice multiplication for each of the problems, but I'm only wanting to do D. which is multiply 4,952 by 243. And with lattice, you're always going to use this box. One number goes on the top, and the other number goes on the side. And then you multiply each of the digits by themselves. So 2 times 2 would give you 4. 2 times 5 is 10, and so on and so forth. You can't forget the zeros. Zeros are just not unimportant. You can consider them placeholders so you don't accidentally put a 4 here, or because 10 is a lot different than 1 when you're adding. So once you multiply all the little factors, this is where knowing your multiplication facts are going to come in handy. Then you're going to add down diagonals. So 6 is by its lonesome, so we're just going to bring down that 6. 5 and 8 is 13. You can't keep 13 all the way down here, so you got to drop the 3 and carry a 1. So 1 plus 4 is 5, plus 1 is 6, and 7, and that's 13 again. Drop the 3, carry the 1. Make sure you're not mistaking that as 10. One number per triangle, unless it's a carry. So you got 1 plus 2 is 3, 9, 11, and another 13. I hope that's not an unlucky number for us. Got 1 plus 1 is 2, 10, 13, 19, and 20. Changing it up a little bit. 0. That 0 is very important. And then we're going to carry a 2. So 2 plus 1 is 3, 11, and 12. So drop the 2, carry the 1, and 1 plus 0 is 1. So you got 1. Because now you're just going to write the numbers in order from left to right. 1, 2, 0, 3, 3, 3, and 6. Put our little placeholder commas. Got 1,203,336. See? Not too hard. It's a very easy way to break down multiplication if it's a really big number. And number 5. Let's read the question. We're going to use rounding to the leftmost digit to estimate the results and then make an exact computation. And we'll discuss it. So our problem is 883 plus 465 over 134. All right, looking at the leftmost digit of 883, you look to the one behind it. If it's greater than 5, we round it up. Looks like it's an 8, so yes. That's going to give us 900. Plus 4 looking behind is a 6. That's going to make us round up to 500. Happy face. Sorry, they were just drawn too close together. They had to be a happy face. All right, and then we're going to divide it by 1 looking behind is a 3. So that's actually going to have us round down. So 900 plus 500 is 1,400. over 100. Ignoring the zeros because they'll be canceled. And you got 14 divided by 1, which is still 14. All right. And now let's find our exact computation. So if you want to get out a handy dandy calculator, got 883 plus 465. It's going to give us 1,348. And then if you want to stop there, you can do 134 plus 8. See how we got that? Because we add them together, you got 1348. Because 1,340 divided by 134 would give us 10 with a remainder of 8. Or you can just divide it by 130. Divided by 134, and I'll give you this big old number. That's about 10 point, oops, my calculator disappeared. 10.0597, lots of numbers. So now why would you want to use estimation or exact numbers? Thinking about like trying to feed people, if you round down, if it's 53, well, you'd round down in that case because 3 is less than 5. But if you do that and order only 50 dishes, 3 people are going to go home hungry and they wouldn't be happy about that. But if you're at a big event and say there are 1,300,000, well, rounding up or down isn't going to change the fact that there was a lot of people there. So just be careful of when you're using rounding versus when you're needing an exact computation. All right, and we only have one more to do. So let's hop on to it. Boop. And it's performing the following operation with a relative base. All right. So what I like to do is I will break apart each of the question. Start on one side and then you'll do the other. And you'll do 4, and 3, and 2. And then multiply it by the base powers. So 5 to the power of 0. I'll work backwards. So 0, 1, and 2. And so then I'll tackle the parentheses together and bring it all down. So inside the parentheses, order of operations says you should do the exponents first. So 5 to the second power would give you 25. I've lost my mouse. And then 5 to the first power is 5. And then if you remember, any number to the power of 0 is always going to be 1. So now we'll do multiplication inside the parentheses. So you got 4 times 25 is 100. 3 times 5 is 15. 2 times 1 is 2. Add them all up, and you get 117. All right, now let's move on to the second part of our operation. So you got 1, 3, and 3, base of 5, so work backwards, 0, 1, 2. All right, remember we got to do exponents first inside the parentheses. 5 to the second power is 25. 5 to the first power is 5. And 5 to the power 0 is 1, always 1. no matter what number. It could be 5 million to the power of 0, still 1. All right, so we got 1 times 25, 25. 3 times 5, 15. And then 3 times 1, 3. And that's going to give you a total of 43. But are we done yet? No. Now we have to add them together because that's what the operation up here said to. So now we have 117 plus 43, and the answer to the problem itself is 160. See, it wasn't too hard. A lot of writing down to do, but pretty simple to get there. I had a great time helping you guys with some math. If you still don't understand, don't hesitate to seek out help, but I hope that these problems became a little easier for you to understand. And hope you join me next time for Module 3 Written's exam. Thank you so much.